Hello students. Imagine we are trying to track a tiny electron zooming around the nucleus, which is moving very fast around it. And I have a question here. Is it possible to determine the position and the velocity of it simultaneously? Surprisingly, quantum physics says no. Welcome to Heisenberg's Uncertainty Principle, one of the most mind-bending ideas of modern physics. Let us find out what is Heisenberg's Uncertainty Principle. And according to him, the momentum and the position of an electron cannot be determined simultaneously. And if possible to determine the position of the electron with more accuracy, then there will be less accuracy or uncertainty in the determination of velocity of it. So let's move more deep into it, where if delta x is the uncertainty in the position of the electron and delta v the uncertainty in the velocity of it, then according to Heisenberg's uncertainty principle, delta x into m delta v, where we know mass of an electron is a constant. When we multiply that with change in the velocity, we'll be able to obtain change in the momentum of the electron. So, delta x, uncertainty in the position of the electron, multiplied with change in its momentum, will be greater than or equal to h divided by 4 pi. Or we can say delta x into delta v, that is uncertainty in the position and the uncertainty in the velocity, if we find the product of it, will be greater than or equal to h divided by 4 pi into m, as m is taken here because it's a constant. So now let us analyze some of the numericals related to the concept. And here is a numerical related to Heisenberg's uncertainty principle. The uncertainty in the position and the velocity of a particle are given as 10 power minus 10 meter. I think that is actually denoting the position, and the velocity is given as 5.27 into 10 power minus 24 meter per second. Calculate the mass of the particle. So this relates Heisenberg's uncertainty principle, where according to him, delta x into m delta v is equal to h divided by 4 pi. If we can bring delta x and delta v to the other side, because we are supposed to find mass of the particle. So, mass of particle is equal to Planck's constant h divided by 4 pi into delta x into delta v. We are provided with the uncertainty in the position as well as the velocity, where that can be substituted here directly. We don't require any conversion here. Directly it can be substituted. And if you multiply and divide with all the numbers what is substituted, we'll end up with 0.099 kilogram as the mass of the particle. So, this is a numerical related to Heisenberg's uncertainty principle, where it is possible to determine the mass of the particle if the uncertainty in velocity and the positions are provided. This is another numerical where you're going to calculate uncertainty in the velocity of a cricket ball, where the mass of it is given as well as the uncertainty in the position of it also is given as 1 degree Armstrong. So according to Heisenberg's uncertainty principle, we know delta x into m delta v, that is change in the position or the uncertainty in the position multiplied with the uncertainty in the momentum, which is mass with uncertainty in the velocity, is equal to h divided by 4 pi, where we are provided with the delta x here, that is the uncertainty in the position is given as 1 degree Armstrong, where we are supposed to convert that in SI system, where it is 10 power minus 10 meter. So now delta v is equal to h divided by, you're bringing all this to the other side, delta h divided by 4 pi into delta x into m. So that is equal to Planck's constant 6.626 into 10 power minus 34 joule second divided by 4 into pi value is 3.14 into delta x, we know it's given as 1 degree Armstrong where we have converted that in meter. So 10 power minus 10 multiplied with mass of the ball as 150 gram, so it is 0.15 kilogram. So multiplying, dividing and all that, we'll be getting the speed or the uncertainty in the velocity of the ball as 3.499 into 10 power minus 24 meter per second. Hope you are clear with the concept.